This work presents and demonstrates ROIAL, a region of interest active learning framework for categorizing user preferences in exoskeleton walking. While previous work focused on gait optimization, this work learns users' entire exoskeleton gait preference landscapes. Categorizing such landscapes allows us to study patterns across users and gain insight into the underlying science of walking. ROIAL identifies a region of avoidance containing gaits that make users feel uncomfortable or unsafe, and focuses learning within a region of interest outside of it. ROIAL learns from peer-wise preferences and ordinal feedback, which assign gait trials to order categories such as bad, neutral, and good. First, we'll illustrate this learning process on a one-dimensional example. Initially, ROIAL samples widely across the action space. After iteration 5, ROIAL stops querying points in the region of avoidance because in that area, the posterior upper confidence bound falls below the region of avoidance threshold. We demonstrate ROIAL's performance in simulation on three-dimensional functions. ROIAL successfully captures the region of interest and learns the utility landscape more accurately as the number of learning iterations increases. After validating ROIAL's performance in simulation, we deploy the algorithm on the lower body exoskeleton Erdem to learn three users' preference landscapes over 4 gait parameters: step length, step duration, pelvis roll, and pelvis pitch. At each iteration, ROIAL selected a new exoskeleton gait for the user to test. The user was asked to give that trial one of 4 ordinal labels: very bad, bad, neutral, or good, and then asked whether to prefer the previous or current trial. This process was repeated for 30 iterations. Here are example gaits in each of the 4 ordinal categories for one of the 3 subjects. After completing 30 learning iterations for each user, we validated ROIAL's learned utility landscape by completing 10 validation trials and comparing the user's ordinal labels with the algorithm's predictions. Here is the confusion matrix for all 3 subjects' validation trials. The first column is gray because actions outside the region of interest were purposefully avoided to prevent subject discomfort. Overall, these results suggest that ROIAL can yield reliable preference landscapes within a moderate number of samples. These learned landscapes highlight both regions of agreement and disagreement among the subjects. For example, all subjects strongly dislike gaits at the lower bound of pelvis pitch and pelvis roll. However, all subjects disagree in the most preferred gait region of their utility landscapes across step length and step duration. This work presents progress toward better understanding the mechanism behind user-preferred walking and optimizing future exoskeleton gait generation for user comfort.